So I think I've got like 30 seconds left. Always excited to see everyone. So that being said, pretty much my time is up. It's getting close to the top of the hour. People are logging in from different continents. We've got Australia, North America, South America, Europe, and yeah, there's probably hopefully a couple from South America. Maybe one of these days we'll get some of the Asia people to wake up to join us. But thank you for joining us for the 12th Global Passive House Happy Hour. I haven't seen Prudence yet, but I will definitely turn it over to Monty. So Monty, take it away.
Monty,
You're muted. Boomer.
Unmute myself. There we go. Okay, we'll try this again. Yes, my name is Monty Paulson. When this Passive House thing doesn't work out, I'm going to make T-shirts that just says "You're on mute, Boomer." I lead the Passive House team at RDH Building Science. I'm tremendously honored to welcome each and every one of you to tonight's Passive House Happy Hour, which is hosted by Passive House Accelerator. This is an inclusive gathering. It's meant to be a place for everyone. We welcome people of all stripes, from all shades and types of Passive House. We even dance with the Living Building Challenge people. So please turn on your cameras. Please turn on your microphones for just a minute. And join me in raising a glass for a toast to all of us who survived another week of chaos and coronavirus. Cheers.
Cheers.
All right, now you can turn off your microphone if you want. Please close your web browsers, close your email browsers, because we have a great lineup this evening. We're going to see a 2-minute video tour of a new 24-unit multi-unit Passive House in Whistler, British Columbia by Melvin Lau of Integral Architecture. And we're going to see a detailed presentation of a community center retrofit by Tom Bassett-Dilley of Oak Park, Illinois. Is Prudence here? Can we turn this over to Prudence? I'm thinking maybe we'll come back to Prudence, and let me just turn this over to you, Zach.
All right, thank you. Appreciate that.
Hey guys.
Hey, great.
Hey,
There you are.
it's Prudence. Hi everyone. I'm sorry that I'm joining late. Bit of chaos here, getting online. Everyone, welcome. Here we are again this week. There's a lot of crazy stuff happening in the world, and I don't know about all of you, but for me, this is a reprieve to just be able to come together as a community, common unity, and enjoy each other's company, whether it's in joy or solace or thoughtfulness. So thank you all very much for being here. And with that, I'll hand it back to Zach.
All right, thank you, Prudence. Thanks, everybody. I just wanted to take a moment to acknowledge what we're going through in the US right now and in the world, and share a couple thoughts. And I want to start with a confession. I have sometimes flirted with the idea that the climate crisis is the problem we need to solve, because if we don't, then all other problems will be eclipsed. The climate problem is already so hard. Can't we just focus on that and let others deal with everything else, right? The thing is, I get to think this way because I'm white. We all know this. I get to choose when and if I actually face up to the anti-Blackness that is behind the deaths of George Floyd, Ahmaud Arbery, Breonna Taylor, Eric Garner, and so many other Black men, women, and kids. I get to choose to tune in or tune out. I get to choose to elevate the climate crisis above the racism crisis. I get to choose, if I want to put blinders onto everything except my work on buildings and climate. All of this is my privilege, except now I don't get to choose. None of us do, really. Racism and its repercussions are rocking our streets, our screens, and our lives. And the police brutality that was once reserved for Black and brown people is now being waged on all of us. We see this on our social media feeds every day, and suddenly we can't ignore what's going on. We know that the white supremacy that is feeding all of it won't just magically disappear. So we can either accommodate racism or work to dismantle it. Now, I don't pretend to have the answers to how that's done, but there are lots of Black, Indigenous, and people of color thinkers and writers with wisdom and guidance to share on that. and I'll share a link to one resource in chat in a bit. But today I want to say to the people of color who are here at this happy hour that I am so glad you have come. You and your full authentic self are so very welcome. We welcome your insights, your curiosity, your contributions, your challenges, your energy, your fellowship, just you. To my white brothers and sisters, I submit that this is a time of reckoning. We can't pretend to be working for climate action if we are not also working for racial justice. First of all, we need a real functioning democracy to make change and to shift away from fossil fuels. We clearly don't have that in the US now, and will not until we address anti-Blackness and racism. Second, the struggle for climate stability is fundamentally a struggle for people. Ultimately, the Earth will be fine, but humans, that really depends. So we act on climate because we care about people. And doing climate work, but ignoring the dehumanization of Black and brown people right now, today, makes no sense. So we need to incorporate anti-racism into what we do as passive house designers, builders, and advocates. Let's seek out stories and wisdom to guide us in this effort, accept that it will be uncomfortable, and support one another to do the work to make it happen. Thanks for listening. Over to you, Monty.
Thank you, Zach. I think we all really appreciate you sharing that so much better than most of us can articulate it. We are an inclusive gathering. We do welcome newcomers. We want to meet you in the breakout sessions, and we want to see your projects, things you're working on, in the form of 2-minute video tours. We have a great 2-minute video tonight by Melvin Lau of Intric Architecture here in Vancouver. I've known Melvin for several years. He cut his teeth designing a large townhouse project to the Passive House Center in North Vancouver. Client decided to go another way and not finish that as a passive house, but I watched Melvin struggle through a lot of thermal bridging details on a tough parkade. And then I had the joy of watching him apply his deliberative diligence and fierce efficiency to this 24-unit workers' housing project in Whistler. Take a look.
Welcome to the 1020 Legacy Way Passive House Apartments. This project is located in Whistler and was completed in 2019 and consists of 24 bedrooms on 4 floors over a level of parking. The overall shape of the building is fairly simple, as you can see with these long straight walls. The simple form makes it ideal to use prefabricated panels. Using the BC Passive House system, the walls have an effective R value of 45, the roofs of 98, and the floors of 71, ideal for Whistler's climate. The air barrier is taped interior OSB on the prefab panels and the concrete of the suspended slab. We did have some issues during some cold, wet weather, so membrane was added as a safeguard. The project team rethought platform framing, so site assembly was like stacking Lego blocks, and air barrier continuity would always be on the inside. Less wood plates were required, which helped to reduce thermal bridging. One of the most prominent features of this project is this entry canopy. The structure is independent of the main building and hidden within these vertical walls, meaning no thermal bridging and a clean look. Here we have the certified passive house door. By Veta, the frame is made of solid pine, exterior insulation, and aluminum cladding, in addition to the standard triple glazing, triple gasket, and multi-point lock. On top of the attic are 2 grills for the intake and exhaust, serving the centralized ERV unit. From there, the ducts extend over the corridor in the attic before branching down to serve the suites. The heating and cooling are partially provided through heat pumps, utilizing the DES, or District Energy System, then to the ERV. The DES generates heat through the neighborhood sewage in a 2-pipe closed-loop system. Or another way of thinking about it is an HRV, but with poop instead of air. Starting from the entry, here's a basic rundown of a standard unit. The kitchen has an induction stovetop with a recirculating hood, complete with a built-in grease and carbon filter. Hidden within the kitchen wall bump out is the plumbing stack with 2 inches of pipe insulation. The windows beyond are similar to the door, but function on the tilt and turn operations. Below that is the electrical baseboard for supplemental heating. This storage room helped create the simple form and the HVAC layout flexibility. Hidden in the storage room ceiling is the suite's react dampers for the ERV unit. The final PHPP numbers are a heating demand of 13 kilowatt hours per meter squared, an air tightness of 0.15 ACH at 50 pascals, and a PER of 62 kilowatt hours per meter squared.
All right, I think everybody is back. So I'm go into some quick announcements, and then we'll move toward the meat of the program here. The first two announcements are about videos, and North American Passive House Network is still accepting videos for their virtual building tour competition. So you have not missed your chance. If you can get your video together in the next week or so and get it to them, you'll be in good shape. It sounds like we were speaking with Kevin Levinson about that earlier today. The International Passive House Association is still accepting videos as well for its virtual International Passive House Open Days. Those are due June 19th. FIAS is starting a CPHC online training on June 8th. So you can register for that with that link. I'll send all this in chat as well. And 475 and our own Sean Stanamore are involved in a webinar, are teaching a webinar about passive house CLT and air tightness for multifamily buildings tomorrow. You can see the times and the link there. And I think Sean mentioned the Building Science and Beer Show. Tomorrow will be a pretty great one about how to build a pretty good house. Finally, I want to thank our founding sponsors who make all of this possible. Mitsubishi Electric, Zola Windows, and RDH Building Science. And I'd also like to thank our patron sponsors, Marsh & Hirschfield and 475 High Performance Building Supply. So with that, I'll hand it off to Prudence, I think.
Yep, thanks, Zach. Thanks for all of those great announcements. It's great to be kept in the loop every week about what's going on. So it's my pleasure to introduce you all to a couple of gentlemen joining us from Illinois tonight, Tom Bassett-Dilley and Timothy Eberline. And Tom Bassett-Dilley is an architect. He got interested in architecture in high school when he found a Frank Lloyd Wright book in the library and got hooked, fascinated, and inspired. And then via Ed Mazaria, Frank Lloyd Wright School of Architecture, through Ball State University, and then Columbia for grad, he found Passive House. And he became a consultant in 2010, and then quickly got more involved as a founding member and past president of the Chicago Passive House Alliance US chapter. And in addition to everything he does in the passive house world, he is a creative guy, a guitarist, a gardener, and a great painter. Check out his Instagram feed. So he lives in Oak Park, Illinois with his wife, 2 kids, and their dog and cats. And then Timothy also works for the same firm, Tom Bassett-Dilley Architecture. And he's an architect and a builder. We love those guys. And his design standards, coupled with his construction knowledge, practical solutions, and really great communication, have really been a boon for their projects in terms of conveying the design intent through the whole construction process and into implementation. He lives in Park Ridge, Illinois with his wife and 3 daughters. And today we're going to be hearing about their FIAS Plus Source Zero Community Center project. And for those of you who aren't familiar with FIAS Plus Source Zero, the building has to generate or produce as much renewable energy as it uses on an annual basis based on the source energy, right? So we're using the primary energy or source energy multipliers and then offsetting, essentially taking that number all the way down to 0. And they're doing that with this project with all on-site renewables. So without further ado, I will pass it off to Tom. There we go. Success.
I got it. Thank you. Sorry.
No worries.
Slide. Okay. I'm on a wide format too. I hope that works for everybody. So anyway, yeah, this is our kind of 2030 for 2019. So we're really excited by this. We're inspired by it, and fortunately, we have clients who come to us asking for it. So as a 6-person firm, it's our focus. It's what we live and breathe. This is just a snapshot of some of the projects, most of our net zero and passive house projects in the last 8 years or so. And the bottom right corner is one that we're really excited about, which just is kind of coming on board, which is a retrofit of a Frank Lloyd Wright house here in Oak Park. So, all right. So the Carroll Center is a community center in Oak Park. It's a little kind of building that was originally built in the 1920s designed by John Van Bergen, who was a Frank Lloyd Wright employee, and then went out on his own and did Prairie School buildings. Then it was added on to in the 40s and the 70s. So there's kind of a mishmash of things that we were coming into. The rendering in the lower right shows kind of the big addition off on the left there, which is our project. The owner started by saying, listen, we need an addition here, and we want to, keep the budget down. So we designed a down and dirty addition, got the bid, and then they took it to the board, and the board said, yeah, but can't we do better? Because we had done a project for the Park District 4 years before that's a near net zero project that the community loves and the board is proud of. And so we got together with the Park District again and said, hey, the Illinois Clean Energy Community Foundation grant might be the ticket here. So this is a pretty amazing incentive program that we have in Illinois, because ComEd, the big utility, I think they sold a power plant, something they had like a $225 million amount of money that had to go back to the public. So they did it via this endowment that funds more efficient, energy efficient design. About 5 years ago or 4 years ago, they decided to take it from just funding lead projects to making it net zero. If you're going to get the big grant from them, you have to make a net zero building. So they give you like 60% of the money during construction, but the last 40% comes after you've proven a year of net zero energy. So the pressure's really on to deliver, and you have to choose a third-party certification, ILFI or FIAS, and so we did FIAS. So we got pre-certified, and really one of the big reasons for that is the kind of quality control that we know is going into checking the energy model, checking the construction, and knowing that the building is going to perform the way we think it's going to perform. Because if you don't have the quality control, you could be missing something big and not prove out your net zero. So anyway, we went in for ICCF grant, and it was approved for nearly a third of the construction cost, because what we were doing with the old building before was basically just repainting the inside. Now we're gutting it, and we're making it airtight, and we're insulating the heck out of it. And so it was a big change in scope, but that's what the grant is there for. I'm going to plug in my phone so I don't lose my power. So anyway, so that was a big deal. This is a quick orientation here. On the top is the existing zone of the plan, and on the bottom with the black fauché is the new section. So Oak Park has got more young families moving in. There's more kids. We need more after-school programming space. We need more daycare space. And the Park District wanted a big room where the entire staff could meet. They don't have any facility big enough to have their entire staff. So that's what this big addition was about. That's why the ceilings are as tall as they are, because they have kids in there running around throwing balls and stuff after school. And that's why there aren't a lot of windows down low. And then there's a movable partition down the middle so they can divide it up in the day for daycare. So the total ICFA for the project, the conditioned floor area per FIAS is 7,667 square feet. But you see the envelope to ICFA is about 2.7. It's kind of a sprawling building. So that's a little challenging in terms of energy modeling, as we know. So this is how we did it. The new construction is basically concrete block painted on the inside. Simple, cheap, durable. And then, you know, when you think about like the perfect wall from Building Science Corp, this is pretty close to that, isn't it? We've got an air control layer on the outside of that, which is the fluid applied, the orange stuff there. That's a Prosoco Cat 5 membrane, which Timothy will talk about in detail. He still has it, I think, in his clothes.
It's still on my coat.
Yeah. And then we've got our thermal control layer outside of that, which is 6 inches of mineral wool insulation. And then we have our water control membrane on the outside of that, which is the siding. Although the Cat 5 is acting as basically our drainage plane, we're flashing all the windows to that. And then we're wrapping up and over with our air tightness. We put a piece of Zip R, which is an insulated sheathing board, on top of the top course of block. And we basically extended our air tightness over the top of that and down, and our roof membrane is our airtight layer for the roof. And so that's fairly straightforward, I think. I mean, having done a number of passive projects, there were details to work out, like at the sill was kind of tricky with moisture and whatnot, but we did it. And then on the retrofit, it's kind of a different story. And I just want to kind of go into this saying, like what somebody else said earlier, we've done a fair amount of these, but I definitely don't feel like we have all the answers. I think that we have a lot of gumption, which I think is like equal parts bravery and dumbness or something. It's like a fearless willingness to go and do things and try them out. And we have made some mistakes, and I have presented to the Passive House conference about some of our mistakes and what we've learned. So hopefully we're not making too many mistakes here. We go to, you know, Building Science Corporation and all of you people in the community to learn and try to avoid it. But so on the retrofit side, we initially went into this trying to figure out if we could do it with cellulose, and realized pretty quickly that we had so many ins and outs that we decided we would retrofit this with spray foam. And so we sistered down the rafters, which are 2x4s, with 2x8s. And that allowed us to straighten out the ceiling and account for the deflection, leave the deflection alone in the rafters that are there, sister on. That gives us over 8 inches of closed cell. And then the wall assembly, we cross-furred. So on the inside face of the 2x4s that existed, we put horizontal 2x4s at 24 on center. And so that gives us something to attach the drywall to, but it breaks the thermal, it creates a thermal break. So the studs aren't coming all the way through. We got an 1.5 inch cover over them. The foundation, we just spray put on the inside. So you see that over on the right, I can't because I have people's faces there. But we basically put everything on the inside. So on top of the existing slab, we put a raft of insulation, put a new slab. So it's a shorter basement. On the inside of the foundation, we spray foamed it. So we basically were able to eliminate most of our thermal bridging that way, and kind of worked our way up the roof. Obviously, we have a little bit where the floor joists come into the foundation, but not too bad. I'm going to move quickly here. These are window details we can come back to. We used Alpine windows both at the new and the existing, different ones based on what we needed. For mechanical systems, we used a geothermal or ground source heat pump. It has a high COP, which is nice. And that lets us do all the heating and cooling with our ground source. Ventilation is with the Renew Air unit. That's you know, our energy recovery ventilation. And then domestic hot water is very limited. There's just a couple of bathrooms. They're not used a ton. So we just use a simple electric water heater for that. And then we need to get to zero energy, right? So we put a huge array on the roof, and our client, Chris, you're listening, I'm sure, he is just an absolute hero in the village and in the region. He's been outfitting Park District with solar for years. And so we're actually going over and above what this building needs, because here's the thing with that grant. We got to make sure we hit 100% or we don't get the last 40% of the money. But we're also, by overproducing a little bit, we're working out a arrangement with ComEd to see if we can kind of treat the overproduction as community solar, basically. So anyways, it's a 27 kilowatt rated array. It's a bunch of power, 79 panels. You'll see them here in a second. So here's Wolfie Passive. I'm not going to delve into this too much. Pretty complicated utilization pattern. We had to get in there, all the kids at the different times and adults at different times, evenings and weekends. What we learned from our previous project with Park District is that, you know, as we all know, there's no such thing as a net zero building, just buildings that are used to be net zero. So you have to really be careful about your utilization, and you have to be conservative when you're using the building, or else you could throw that off. You'll notice the one red X on heating demand. This was one of the last projects that was allowed to have, or I think you need to have all green check marks now with 2018, but we were allowed to have one that didn't quite meet at the heating demand, and this sprawling building definitely made that a big challenge. So we got pre-certification on my wife's birthday in 2019. Nice birthday present. All right, now we're going to dash through some construction photos. I'm going to turn it over to Timothy to kind of take you through, because I should just say before we do that, the Park District, we went out for bid for this, and we got those kind of like, oh my God, bids. And they asked us to construction manage it. And we said, well, listen, we haven't done that before. We'd love to, because we've worked with you a lot, and we have a great relationship. We kind of negotiated how that would work and what we would do and what we would not do. We're not taking builder's risk insurance, et cetera, but we're lining up the subs. And then, of course, what happened was Timothy became the instrument to this being a successful passive house project by looking out for all those details that so easily can get missed, particularly the air barrier. So anyway, Timothy's training is architecture, but he's one of those rare individuals that goes very smoothly into the field and into the office. So anyway, Timothy, take it away.
Thanks, Tom. Just on that note, I want to take a quick moment to shout out to Chris Lindgren. Every great project starts with a great owner, and Chris, it's been great to work with you in the Park District of Oak Park. Thank you for being an adversary for causes like this, where firms like TBDA can build great projects. So Tom did a great job breaking down kind of the nuts and bolts of the drawings of the project. We're going to dive into some of the construction photos. What you see here is insulation of the existing and new foundation. In the existing building that John Van Bergen designed, we put 6 inches of EPS on the existing slab, and then we used 2-inch foam around the edge, not only as a thermal break from the old foundation wall, but also as a screed for them to put the new concrete slab on there, just a little bit of an isolation joint, made it easier for them to do. In the middle, you can see a photo of insulation preventing a thermal bridge. That's an exterior uninsulated foundation retaining wall at the intersection of our building. So it becomes very critical when the concrete guys are pouring to have all that foam on site and make sure that it's all there, because if it's not there, the thermal break isn't happening. This is just a little bit, a few more photos of the foundation. One of the parts of the foundation that's important is you can see the peel and stick membrane on top of the foundation wall. That's the capillary break. A lot of you know that the capillary break is very important. There are different locations where you can put the cap break. In this particular project, we did it on the top of the wall. Another contractor did that portion of the work. I did not do that portion of the work, but essentially after that portion, the air barrier work came down to me and Chris Lindgren of the Park District. You can see the worker there is applying the damp proofing that worked as the essential preliminary adhesive to keep the exterior insulation on the wall. And then the other photos on the right, you can see there is actually a pier there that was not located properly. So we had to cut back to the control joints and make sure that the pier was located properly. I located it properly with the concrete contractor the morning of. And then when I came back, he fell back to an old set of drawings and whatever. There's, things happen in construction. But the point is we got past it. It got insulated properly. The stego wrap was continuous and life goes on. Tom started to talk about this before, but I think this is probably of interest to some of you. When Tom first approached me about this project and being the construction manager, the thing that I was most scared about was the air barrier. I've worked for him for long enough to know that consistency in the air barrier is important, along with consistency in insulation. But on an existing building such as this, we're stuck with a bunch of conditions that we have to deal with. So originally, the air barrier strategy was to use an aerosolized product called Aero Barrier. And I met with the local individual on site a few times and we talked through it. And he let me know that because the Aero Barrier is a proprietary product, it's very expensive based on the amount of product that you use to fill in the gaps. And so this building with the shiplap sheathing that was present on the walls and on the roof, the amount of material that was expected to have to be paid for to fill all these gaps was going to be astronomical. So we had to do something that we don't like to do. I've learned working for TBDA, Tom never really likes to use closed cell spray foam or spray foam as an air barrier. And in this case, we really didn't have much of a choice. And frankly, doing a building like this, part of this is education and seeing how things work. We moved forward. We talked through it. We looked at AHR values. We talked to some other consultants. We moved forward with the strategy that we weren't going to use Aero Barrier because it was going to be too much of a change order to the client. We were going to close cell spray foam the walls and the roof. And as Tom mentioned before, the walls and the roof were made more robust so that we knew that we were meeting our R value targets. But really the fear in here was not being able to get it air sealed properly. So the plan was
just to jump in there quickly, I think we had the Aero Barrier in our back pocket, but they said you better spray foam it first, because if we try to, we knew we were going to spray foam for insulation. They said you better spray foam it first because that'll reduce the amount of Aero Barrier you need by a huge proportion.
Absolutely.
And so we did that, and then we tested it, and we made our air barrier, we made our air tightness.
Yeah, originally the step one was just use all Aero Barrier, and that was overruled. And so next the idea was to use it after we spray foam, just to fill in the other potential gaps and cracks that have formed. But we had the great readout from the first blower door test. Our third-party raters were like, yeah, we don't think you need it. And part of that process was using the Prosoco products of joint and seam filler and air dam in the existing building to really fill in and create a consistent air barrier wherever possible. I know I'm kind of going on about this, but the air barrier in the existing building is really important. One of the things that we really took pride in, and that isn't typically done, is that we, once the demo was complete, we vacuumed out all of the sill plates and made all of the existing framing extremely clean, not only to help the building properly deal with moisture moving forward, but to also any gigantic gaps or large gaps that were in the sill plates or in the sheathing or in the wall to roof connection were filled with backer rod and then used. Joint and seam filler was mostly used because it's the best product to bridge the large gaps. So at the end of the
We
day,
got some photos here. Yeah.
Yeah. These are a few photos of kind of the frame connection of the old and new. It's a great concept, because one of the great things about this project is that not only are we preserving an old building that's worth preserving, but we're literally branching out and attaching it to a new structure. Mostly the idea of the new framed connection was it's a zip sheathing air barrier. Zip sheathing is great to work with. You can see a bunch of the tape there, but they also have a great liquid zip product, which came in very handy on this project. The other photos, you can see the kind of connection to the rough CMU box there. We're going to get into photos a little bit later of how we dealt with the air barrier there. And then you see kind of almost at the end there where they're putting the final cement board panels over the horizontal hat channels, over the Cascadia clips with the Z's on the exterior insulation. So you're starting to see the building start to take shape there. This is just a little bit of a breakdown of kind of some of the trials and tribulations of trying to make an existing building airtight. It is doable. It's a daily battle. It's something that you need to kind of have conversations with your subs about and make them aware of. I need to do this before you do that, because if you do that, this, I can't do this. So the zip tape you can see on the left is almost part of a process. That tar paper that's there is part of the existing building that was laid over the existing shiplap sheathing. So later on, we went back and zip taped that in. In the upper right corner, you can see one of those moments that I was describing before. Those are plywood pieces that are put in every rafter bay. And then backer rod was put around the edge and joint and seam filler was put in there just to create some type of consistency in the air barrier. We knew that that was a gigantic spot of leakage, so we really focused on the top of the wall. And then the bottom right photo you can see is a little bit more of the air barrier kind of construction of the old to new. You can see the brick wall there on the right, and then it's the zip sheathing that's all taped, and the roof is there, and you can see the parapet, and that's actually the main entry of the building there. This is Chris Lindgren. I know you're smiling right now. Another shout out to Chris. We did the Cat 5 air barrier on the CMU. I know a lot of you guys are really intelligent into their stuff. I will say Prosoco has a great team. They're amazing to work with in the field. Everything that they say on the website about them is true from my experience. They go above and beyond and out of their way. The problem on this particular project is that the CMU as a substrate for an air barrier is way too porous. It took more coats than we were told to get the wall coverage. This is what's known, that's me over there on the left, putting on the KISS coat. It's supposed to be the primer coat for the Cat 5. And we ended up going around the building several times. But at the end of the day, the lesson learned on Cat 5 is that the substrate is important for specification for you architects out there. If you are putting it on a substrate that's not, a sheathing product or something that comes from, zip or wherever it may be. So that basically took the whole month of December. And then you can see there in the photo in the middle, that is the continuation of the air barrier transferring up to the framed cap that Tom mentioned before. So essentially the CMU wall goes up. We put joint and seam filler at the connection between the CMU wall and the zip cap. And then that's the zip tape that's indicated there, essentially fastening airtight connection of the TPO to that framed buck that we're using at the top of the parapet. A couple of the other photos there are, you have the air barrier at the wall, but you also have the air barrier at your windows. So you can see the fast flash coming in there on the interior, and then you can see the air dam, which spans the gap from the window frame to the fast flash. So there is backer rod back there to span the 1/2 inch gap, and then that's an air dam, which is also another great product from Prosoco. This is a slide to depict one of the more difficult parts of the project, which is doors. These are actually photos of the aluminum storefronts. You can see in the first two photos on the left, there's a piece of stego wrap there that's kind of loose, and that was taped with the stego tape. And then we used the Prosoco products just to get a good seal there at the capillary break and the stego wrap. The other two photos, sorry, the other two photos are great photos of the existing building, trying to get that air barrier as consistent and thorough as possible. One of these is showing the aluminum storefront, and essentially what we ended up doing here is putting a buck on the framed wall that then we were able to use a can of spray foam to create consistency to then apply the fluid applied air barrier at that jam. And the other photo is a tricky sill connection, which once again is just simply Prosoco products, which are just gooped in there to really just protect the building and create continuity in the air barrier.
We made it.
This is one of the better days on the projects. I have to admit, I lost sleep before we got this first blower door test. There's just no way of knowing as you're working through construction. But anyway, we hit our targets without having to use the aero barrier. And that was an amazing day based on all the hard work on a daily basis that we did to get the air barrier to work. Tom, you want to talk about the solar? I can chat a little bit. Essentially, we used these threaded rods that were epoxy doweled through the CMU. You can see there that part of the air barrier daily activities is to make sure that anybody that penetrates the air barrier, anybody that penetrates that outside wall, you have to be there with some type of goop to put it in there. So this is a little bit of the follow-up, and then you can see how the steel shafts were put on threaded rods to make sure that we weren't compressing the cement board. And that gave them the ability to mount the solar racks for the shading fin on the south. And then you can see the full solar array there on the roof.
Yeah, a little bit of a, Sunmoto is the company that makes these PV racks. I call them Sunshield. But normally you're just going to like attach that to a wall, but we had, 6 inches of insulation that we wanted to run continuously there. So we worked with our engineer to come up with this threaded rod connection. So that's how that worked. I'm sure we're over 15 minutes, but that's it. They didn't cut us off. We made it. Happy to take questions. However, this next session works.
Absolutely.
Yeah, Tom, Tim, bravo. I do have a few lined up. So we're, again, we've got about 8 minutes-ish for questions, and then the rest of them will have to go to the after hour. So the first one is, could be a lengthy one, and maybe it'll help, again, continue in the after hour. But this was Jennifer that started way earlier in the event. How do you get your clients as early as this to get into Passive House?
Oh yeah, I saw that question come in when we were talking about costs early on. And it's funny because, we're in a really kind of great situation that people come to us kind of asking for energy efficient or just asking for Passive House buildings. So it's not a hard sell for us. I think that the difficulty that other people run into is somebody comes in and says, I want, 3,500 square feet and, all of this gigantic kitchen and outdoor amenities and a pool and all this, and my budget's this. And then you say, okay, well, let's make it Passive House. And they're like, oh, is that going to cost more? So it's really a question of what do you want? Do you want an energy efficient building? If so, we'll do that for you. And I think, Jesse Thompson has been I remember reading something great on his website about that. So anyway, you can't just sort of shove it on at the end. And I think the important thing is to talk to people early and try to draw them out on it. Say, are you interested in this? I don't know. I fortunately don't have to force it down anybody's throat.
Gotcha. Graham, I know you've got 3 questions, so ask one of the 3 and then we'll do the rest later, okay? I'll let you pick, but I'm sticking to one because there's other people in the queue. Come
Graham
on,
Irwin?
Yep.
All right. What's up, Graham? Unmute yourself.
Boomer, take care of things. Come on now. All right, I'm going to have to pick one of your questions for you. Oh, I guess he left. I'll have to put him back in the queue. No, he had his first question, sorry, was it seems like low R values for Chicago. Is that because of internal heat gains?
Yes, there's a huge population inside this building. And it's FIAS Plus 2018, where it's not really, it's not like PHPP or 4.75 numbers. In general, the 2018 standard or evolution of the standard has been requiring slightly less R values, but internal gains are big. And we've got I think 60 people in here all the time. So yeah, a lot of ventilation losses, a lot of heat gain on the inside.
And Ken, you had a question? Ken, you still there?
Yeah, I am still there. I had a bunch of questions, but I think the one you're referring to is wondering if you looked at the Deep Energy Retrofit Builder Guide from Building Science Corp.
Well, I mean, I've got the Builder's Guide to Cold Climates, and I've got I'm online there all the time. I don't have that specific publication, but I mean, from having attended a lot of talks by Joe and others from Building Science Corp, these are things that have been on my radar for a while. Is there a specific kind of technique or approach that you were that made you ask that?
Yeah, I think I was just wondering where You know, you mentioned you use their resources a bunch, so I was wondering if that was one of the resources that helped you figure out how to tackle existing buildings and retrofit.
Yeah, I mean, in general, we're, especially coming from a passive house standard, we're looking at the building as a whole with the intended use and number of people inside it, the gains that it's getting in terms, in the losses through the skin. And we know that we're going to have to treat the entirety of the building to some degree to get it to reach a standard of performance passively. So we know we're going to do retrofit insulating. And so it really comes down to us, this is what's great about having WUFI Passive as part of our design process, is that we can start to iterate different R values on different materials, different window performances, and see what it's doing to the energy balance. And so, so that kind of is a starting point. We kind of know what performance we need out of all different parts of the building. But then it comes down to like, okay, how are you going to do that? How are you going to put that R value in that wall or on that floor? And that's where we start to turn to resources like Building Science Corp to see what our recommended uses. For instance, when we do masonry retrofits, we know that we can spray foam up against the back of brick, but if we want to put cellulose up against the back of brick, we better have a capillary break there. So these are things that you don't want to have to learn the hard way. And I got to say, 475 Supply is awesome with their publications similarly about how you can do a foam-free assembly or do like a cellulose retrofit on brick. It's really important to share this knowledge. So yeah.
Thanks, Tom, for that shout out. Harvey.
Thank you, Tim, Tom, great presentation, and thank you. With a lot of knowledge here. Funny enough, as an aside, we're taking a house in Toronto, and we're looking at making it Frank Lloyd Wright basis on the horizontal lines. But be that as it may, one of the things that I just noticed on your presentation, and I was just curious on, why didn't you just break the slab up? And because I know you said you lost ceiling height, floor to ceiling height in the basement, why don't you just break the whole slab up, re-insulate or overly insulate the basement slab of the original house?
White old guys with beards.
Hey,
Yeah,
just making fun of that beard.
We do that sometimes. The basement didn't need to have more height, and with a slab already there, it's a nice, clean, easy substrate. You don't need to demo anything. You're going to put a new slab in anyway, So I guess
was it a cost issue? Was it a cost issue? Was that one of the
It was
other
a bit of a money saver.
It was a money saver. Okay, thank you.
Also, the Park District was just using the basement as storage area. It's not habitable space. So, I mean, I hear you, and I think typically when we can do that, we absolutely do. In this particular case where we didn't have to, we kind of just made lemonade and, did the best with what we could. And at the end of the day, the Park District was going to use it again as storage. So we just felt like it wasn't a smart place to put dollars.
Thank you. I thought that was probably where you're going to go with it. Thanks so much.
Yeah.
The one thing I will say is that you need to get your capillary break in there, which doesn't exist in old slabs. So all these old houses we do in Oak Park, I mean, they didn't have plastic membranes in 1909, so that's always a tricky detail or an important detail to look out for. That also lets you, control radon and get a thermal break and all that stuff. So yeah, you can do it over the slab or you can take out the slab and do it, but those are things to think about.
David, fire away.
All right, thank you. So thank you guys for a great presentation. It was super informative. I have two questions, both about FIAS, working with them. You had mentioned earlier that you got an exception, I think, for the heating demand. And I was wondering if you could speak more about that. And then the second part is just a question about the Source Zero part of the certification. And you know, and I'm just, this is more of a, I'm wondering if I'm understanding this correctly. Since you guys are producing all your PV on site, you're basically hitting like source and net zero at the same time, right? It's kind of a, you're getting like that 2.6 multiplier credit because the PV is on site.
Exactly. Yeah.
Okay.
So you can reach the source zero with offsite renewables as well, but then you're going to take a reduction on the source energy value, I believe. I haven't had to do that, so I would actually turn some of this back to Prudence, because I don't remember, on your first question, when the change happened. There was a while that you could take a mulligan on 1 out of the 4 space conditioning criteria: heat demand, heat load, cooling demand, cooling load. We found, especially with 2015, that in Chicago, it was often difficult to make all 4 without just outrageous amounts of insulation. And so it's getting the demand and the load kind of to relate to each other. It really has so much to do with the shape of your building. So what FIAS did is really genius. They came out with a calculator that ties those space conditioning targets to the shape and density of your building, which really makes sense because that kind of takes into account internal gains and kind of the volume that you're dealing with. If you have a huge building with a few people in it, it's going to be a different set of criteria than if you have that same size with a lot of people in it. So it's I'm not being very technical here, and this is where having Lisa White in the room would be great. But yeah, so I think we were at the transition point there where we could still take an exception if we had to. And I meant to look back at that and see when that changed and how that worked. But yeah, I went and found that pre-certification letter and, just checking what the date was. So what was that, 2019 of September, right, Timothy? Was that right? Yeah. So
sounds right. Yeah.
This is under the 2018 system?
Yes. But but there was a mid-cycle tweak, they called it, where they went to the calculator instead of just the values that they would give you. So sorry, I'm not being as intelligent about that as I should be.
That's all right. Thank you.
No worries, guys. We'll come back to that, those questions in the after. I've got a full list, but let's turn it over to Zach.
Okay, great. Yeah, thanks, Tom. Thanks, Tim. I know there'll be a lot more question and answer stuff happening soon in the after hour. I wanted to let everybody know that we have a great presentation lined up next week with Yale Santo Pinto and Graham Stewart of ERA Architects, ERA Architects, and they'll be presenting about a passive house retrofit of Ken Sobel Tower in Toronto. So it's pretty exciting continuation of this retrofit theme. And with that, Prudence.
Hey, so thank you guys very much for being with us and presenting, sharing your project. That was great. David, I'm happy to answer those questions offline with you and clarify. I have sort of an inside track being on the FIAS technical committee to how all of that stuff works, and I'm happy to share here in the after hour if other people are curious about it also. Thank you all for joining us, and we would love it if you would stay into the after hour with us. Just as a little teaser, we've been having some really fun stuff come up in the after hour. Last time we talked about all kinds of ventilation stuff, range hood design, essentially induction cooktops versus gas, particulate matter, indoor air quality as relates to kitchens. There's always really interesting, fun, and sometimes great technical resources that come up in the after hours. So if you can stay today, we would welcome you, or if you want to plan to stay sometime in the future, it's a really great and enriching place to hang out. And with that, I'll pass it back to Sean.
All right, well, that concludes another happy hour.